I want to prove that square root of 3 minus square root of 2 is irrational. So I'm going to do this by assuming that square root of 3 minus square root of 2 is rational. So this is going to be a proof by contradiction. Assume the opposite is true. So by definition of rational, we can represent square root of 3 minus square root of 2 as a ratio of two integers. So here P and Q are going to be integers where Q is not equal to 0, and P and Q have no common factors. This means I cannot simplify P over Q. So if I square both sides, I'm going to get 3 minus 2 root 6 plus 2 is equal to P squared over Q squared. So 3 plus 2 is 5, and then we have 5 minus 2 root 6 is equal to P squared over Q squared. If I subtract by 5, I get negative 2 root 6 is equal to P squared over Q squared minus 5. And I'm going to divide both sides by negative 2. So I have root 6 equals P squared over negative 2Q squared plus 5 over 2. And if I really want, I can combine these into two fractions. Into one fraction. So I'm going to multiply by Q squared, top and bottom. So the common denominator is going to be 2Q squared. And it's going to be negative P squared and 5Q squared. So I'm just going to write it like this. So on the right, we have a fraction of integers. Okay. So one thing to note here is integers are closed under multiplication and subtraction. Okay. So if I have Q as an integer, I square it, I get another integer. I multiply that by 5, it's another integer. And I'm subtracting that by P squared, which is another integer. Integer minus integer is integer. Okay, so on the right side you have an integer. On the left side you have square root of 6. So here you have a irrational number equaling a rational number. Well, that can't be true. That's a contradiction. So in this case, we say since square root of 6 is irrational, and it's equal to a rational number, we have a contradiction. Okay, this means that our assumption was wrong. So our assumption was square root of 3 minus square root of 2 was irrational, or was rational. That was our assumption. So we're going to say that it is irrational. Notice in this case, I said that square root of 6 is irrational. If you really want, you can prove that it's not irrational, that it's not rational. So just for simple exercise, we'll prove that it's irrational. So prove square root of 6 is irrational. So this one we're going to assume the opposite. Assume it is rational. And because we're going to assume it's rational, we can represent it as a fraction of two integers where the denominator is not 0 and P and Q are in the lowest terms. In other words, we cannot simplify this fraction. So if I square both sides, I get 6 equals p squared over q squared. And I multiply the q squared over, I get 6q squared is equal to p squared. So p squared has a factor of 6, or is a factor of 6. Okay. So that means that p must be a factor of 6. Just think about it. If p squared is a factor of 6, p is a factor of p squared, that means p is a factor of 6. Kind of like transitive property. So we can write p as a multiple of 6. Okay. So I can plug that in back into my equation. So I can say that 6q squared is equal to 6k squared. And that's going to give me 6q squared is 36k squared, which q squared then is 6k squared. In similar logic, we say q squared has a factor of 6. And that means that q has a factor of 6 as well. So we can represent q as a multiple of 6. Okay, so this is what we have. We have p is a multiple of 6, q is a multiple of 6. If I look at my fraction now, I would write it like this. And notice they're not at the lowest term, right? Because I can divide this, I can divide both by 6. So it contradicts this assumption that my fraction is in lowest terms. So I get a contradiction, and my assumption is incorrect. Okay. So this assumption is wrong. Okay. So the opposite is true. That makes the square root of 6 irrational. And that completes the proof.